Figure 3.8, Rods and Cones. The retina is an amazing structure in the human body. It is only paper thin, yet does the most astounding processes, as we will see. It serves to convert light into nerve signals that go to the brain, which translates the signals into vision. It functions as a mini brain, processing many of the visual signals before sending them to the brain. It contains 125 million photoreceptors, some able to respond to colour and some to low light conditions. Because there are more photoreceptors than nerve fibres in the optic nerve, which is only numbers about 1 million, the retina needs to compress the information. As we will see, the retina is wired backwards, so light entering the eye has to pass through several layers of neurons and blood vessels before reaching the receptor cells. Hopefully now you're suitably impressed by the retina and the job it does. Let's see how it manages to do this. Learning something new is always a bit of a journey, and before starting any journey, it's a good idea to map out the landscape first. Likewise, when learning about the body, a good starting position is anatomy. Here are some salient landmarks on the retina. The optic disc is where the optic nerve joins the eyeball. The optic nerve carries all the visual data from the eye to the brain. The optic disc has no photoreceptors, so we should all see a blind spot in our vision. However, the brain cleverly covers up the blind spot by sampling visual information around the disc and filling in the blanks, as it were. The retina is a highly active structure and requires an extensive blood supply through the vein and the artery, which extends across the retina as arterioles and venules. The macula is an oval area near the centre of the retina and is packed with photoreceptors, which gives the clearest form of vision. The fovea is the centre of the macula and is a tiny part of the macula, yet it gives the sharpest images to vision. Now let's look at what makes up the retina itself. The diagram on the right shows a section through the retina in simplified form. There are two main types of photoreceptor, rods and cones. The rods and cones share some similarities in their appearance. The most striking difference is the shape of their outer segment. Cones are shorter and cone-shaped and are found near the centre of the retina, where they produce the sharpest images, in colour and in bright light. There are around 6 million cones per retina. Different types of cone allow us to see red, green and blue and mixtures of all three. In certain inherited disorders, one or more types of cone are missing, giving rise to colour blindness, or more accurately, colour vision deficiency. Rods are important for night vision, and they are highly sensitive to low levels of light. They give rise to black and white vision, and of the 126 million photoreceptors, rods make up about 120 million of them.